This is half past paper week 24, foundation tier and a calculator paper this week. So grab your calculator, make sure you've got it handy, and let's go. All the even numbers this week, and we've got 38 marks, so about half a past paper. Normally a past paper is out of 80, and then we've got all of the Sparks codes there on the right if you do have access to Sparks. Okay, question number 2. Write down 2 factors of 35. So a factor is a number that fits in an exact number of times. So factors of 35, we have 1 and 35, or we have 5 and 7. So you could pick any here from 1, 5, 7 or 35. We've got to just write 2 of those down. You can pick any 2 you like. They don't have to be a pair. I'm just going to go for 5 and 7, why not? Okay, question number 4, work out a sixth of 66. Now, fractions of amounts are about the most common skill that I see assessed on foundation. We're going to divide by the bottom and then multiply by the top. So you're taking that 66 and you're splitting it into 6 equal parts, and then you're saying I want one of those 6 parts. So 66 divided by 6 is 11, and so we've got 11, 11, 11, 11, 11, 11 for each of those sections, but we just want one of those sections, so 11 would be our answer there. Question number 6, simplify A multiplied by B multiplied by 4. Now, when we write algebra and they're multiplying together, we don't tend to write the multiplication signs because it can look a little bit like an X. It can be a bit confusing, so we're just going to write that as 4 A, B, and the 4 goes in front and the letters come after, and we tend to write them in alphabetical order, but if you did write 4BA you would still get the marks there. Part B, simplify 4x, add 3, minus x, add 5. Now we need to collect our like terms. So I've got 4x and I've got minus x. Now remember, that's the same as minus 1x. We don't write ones when it's in front of a letter, we just say it's that letter. So 4x, take away 1x, and that's going to be positive 3x. So I'm just going to write 3x on the answer line, and then I've got plus 3 plus 5, and that all together makes positive 8. Now because it's positive 8, I can write plus 8. If we'd got a negative number, that's when we'd use a minus there in that answer. Question number 8. On Monday, Sandy pays for 2 plane tickets, 7 nights in a hotel and 2 theme park tickets. Each plane ticket costs $600, each night in the hotel is $120, and each theme park ticket is $250. Show that Sandy pays more than $2,500 on Monday. So she's buying 2 plane tickets, so we need to do 600 times 2, or if you would rather, you can do 600 add 600. So that's 1,200 for the plane tickets. We've then got each night in a hotel costing $120, and she's staying for 7 nights, so we need to do 120 multiplied by 7. Now you do have a calculator for this paper, but always good to practice. 7 times 0 is 0, 7 times 2 is 14, so 4 carry the 1, and 7 times 1 is 7, add that 1 is 8. So 840 for the hotel, and then we've got each theme park ticket is $250, and she's buying 2 of those, so 250 times by 2, or you can do 250 add 250. Either way, that's going to be 500, and that's for the theme park. Okay, great, and then we just need to add all of that together. 1,200 add 840 add 500, and again you can use your calculator. I've gone for doing it manually. There we go, 2,540, which is, so I'm going to put 2,540 is greater than 2,500. So there we go, we've shown what they've asked us to show. It's bigger than 2,500. Question number 10. Karina has £300 to spend on books. Each book costs £4.85. Work out the greatest number of books Karina can buy. Well, we want to know how many £4.85s fit in to 300, and that's going to be a division. So we're going to do 300 divided by 4.85 just to see how many fit in, and I'm going to use my calculator for that. 300 divided by 4.85, and that gives me an answer of 61.855670. Now, yes, that does round up, but I can't walk into a shop and say, I've not quite got enough money, can you just round it up and give me 62 books? So we're going to have to round down because I haven't got enough money to buy 62 books. I've only got enough money to buy 61 books. So the greatest number of books Karina can buy is going to be 61, and you do need to write a whole number there. You can't buy 0.8 of a book. Okay, question number 12. The diagram shows two places on a map. What is the actual distance in kilometres from Shelton to Trilby? So we're going to measure this using our ruler, and then we're going to use this scale here. Every centimetre is 20 kilometres in real life. So using my ruler here, if I measure this, I get a distance of 2.5 centimetres when I measure that with my ruler, and I therefore know that every centimetre is 20 kilometres, so I'm going to do 2.5 multiplied by 20 to find out how many kilometres that would be, and that's going to be 50. So 50 kilometres would be my answer there. Again, just use your calculator, or you can do 2.5 times 2 and then make it 10 times bigger. On a scale drawing, the scale is given as 1 to 1,200. How many metres does 5 centimetres represent on this drawing? So what we're saying here, if the scale is 1 to 1,200, that's saying to get to real life, we need to multiply by 1,200. Real life is 1,200 times bigger than on the drawing. So if I've got 5 centimetres on the drawing and I want to know how big it is in real life, I need to times that by 1,200, and that's going to be 6,000. So 6,000 centimetres. So 5 centimetres on the map is 6,000 centimetres in real life. They're asking me how many metres that is, and we know that 100 centimetres is 1 metre. So if I want to now convert from centimetres into metres, I would be dividing by 100. 6,000 divided by 100 is going to be 60. So 60 metres is what 5 centimetres on the map would represent in real life. Question number 14. A stadium costs £600 million. 13/15 of this cost was for the building. The rest of the cost was for the land. Work out the cost of the land. Now, I marked this question as a GCSE examiner, and I remember that a lot of students went wrong here because they didn't know how many zeros to add on for a million. So if you were to do it that way, 600 million is 600 followed by 6 more zeros. So a million has 6 zeros, so 600 million looks like that. However, on the answer line, we can see that we've still got that million. So think of this more as units. 600 million, we don't need to convert it to this. We can just work with it as it is. And then on the answer line, it will still be in million. So a stadium costs 600 million. 13/15 of the cost was for the building. The rest of us was for the land. So if 13/15 was for the building, then the rest, 2/15, would be for the land. So you can do it this way, or you can work out 13/15 and subtract it, but I think it's easier if we just go for 2/15 of 600 million. And we've just said on a previous question that we're going to divide that into 15 parts and then multiply it by how many parts we want. So 600 divided into 15 equal sections. 600 divided by 15 is 40. And then we're going to take that 40 and multiply it by 2, and that would be 80, and that's still in million. So if you did it the other way, you'd get 520 million. If you worked out 13/15, you'd then just have to subtract it. But easier to go straight to 80 million. If 13/15 was for the building, then 2/15 to make 15/15 to make a whole would be for the land. There we go, 80 million for that one. Question number 16. Here's a diagram showing triangle ABC and triangle ADE. Describe fully the single transformation that maps ABC onto ADE. Now there are 4 transformations. There is rotation, reflection, enlargement and translation. I'm looking for one of those because it says the single transformation. I only want to pick one of those words. So I'm going to pick enlargement. This has been made bigger or smaller, but the size has changed, okay? Here we can see that we're going from this one to this one. So it has indeed been made bigger. And what is the scale factor? Well, my original triangle is 1 square tall, and my new triangle is 4 squares tall because it does go from A both times. So therefore, we're going to say enlargement, scale factor 4, and then we need to give the centre. So the centre is the point that it's been made bigger from. And if you connect back the same points, so E corresponds to C, that's the matching point on each shape, D corresponds to B, and A corresponds to A, and normally they're not on top of each other like this, but if we came back with all those points, they meet here at this point here, A. So that is our centre of enlargement here. So centre is 1, 1. Normally, if you had, let's say you had let's say you had a triangle like this and a triangle like this. When you match them up, normally they come back to a point that's outside the shape, and that would be your centre like that, but here they were on top of each other. So there we go. Enlargement, scale factor 4, centre 1, 1. You need to say all three things to get both marks there. Question number 18. Now this one was answered really poorly. I remember the examiner saying how badly this was answered. So this is a bit of a tricky one. Change 1 metre squared into centimetre squared. Now, because it's area, it's not the same as length. So normally you guys would be able to say to me that 1 metre is 100 centimetres. So we'll just times it by 100. And that doesn't work because it's area. And area is two-dimensional. So 1 metre into centimetres is 100, but if I imagine an area, let's do 1 metre squared. So this is 1 metre squared. It is 1 metre in this direction and 1 metre in this direction. If I convert both of those lengths, let's write it as 100 centimetres and 100 centimetres, and then I rework out the area, I'd be doing 100 times 100, and that's going to be 10,000 centimetres squared, 100 times 100. So because it's an area, you need to times it. That would be by 100, but if you're going from 1 metre squared to centimetre squared, you're timesing by 100 squared. So that's why it's 10,000. You're timesing by 100 for the length, and you're timesing by 100 for the height. So there we go, 10,000 centimetres squared for that one, for 1 mark. Question number 20. Here are the heights in centimetres of 15 plants. Draw a stem and leaf diagram. So when I draw a stem and leaf, I like to do a draft one first, where the stem and leaf is not in order. I think that helps to not miss any out. Okay, so I'm going to go, what's the smallest number here? I've got numbers in the 10s, so 10s, 20s, 30s, and do I have numbers in the 40s? No, I don't think I do. Okay, so there we go, so that's it. So 15, I'm going to put here. 20, I'm going to put here. 25, 33, 17, 22, 25, 18, 22, 19, just helps to not miss any out. 32, 35, 24, 28, and 19. There we go. So all 15 numbers are now in my stem and leaf diagram, and now I'm just going to reorder them. So I've got 1, 2, 3 like that for the 10s, the 20s, and the 30s, and now I need to put these numbers in order. Actually, those ones are, so that's okay. 5, 7, 8, 9, 9. And then for the 20s, now I've got to order these numbers. So 0 is going to be my smallest, then I've got a 2, then I've got another 2, then I've got a 4, I've got a 5, another 5, and an 8. And then last but not least, I'm going to order these ones as well, 2, 3, 5. So it has to be in order. Okay, to read this, we need to do a key, 1 line 5. So I'm just using that first number, but it doesn't matter what number you pick. It doesn't even have to be a number that's in there, equals 15. And you can put centimetres there. If you do put units, it has to be correct, so make sure that you're looking at what it is. You don't always need to have units, it's not always obvious what it is. There we go, so 15, 17, 18, 19, 19 is how to read this, and so on. Okay, and it has to be in order. Now the last thing I would do before I leave a stem and leaf is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm happy that I've got 15 pieces of data in my stem and leaf, which means I'm unlikely to have missed one out. There we go. That was question 20, and that was 3 marks. Question 22. Natalie makes potato cakes in a restaurant. She mixes potato, cheese and onion so that the weight of potato to the weight of cheese to the weight of onion is in the ratio 9 to 2 to 1. Natalie needs to make 6,000 grams of potato cakes. So let's draw out our ratio. 1, 2, 3, 4, 5, 6, 7, 8, 9, ... 1, 2, ... 1. So I'm just using these numbers, and I know that all together I need that to weigh 6,000 grams. So now I'm going to take that 6,000 and I'm going to divide it equally over those ratio lines. Now in total, I've got 9, 10, 11, 12 little lines there that I've drawn out. So I'm going to do 6,000 divided by 12. 6,000 divided by 12 is 500. And that means that there's 500 on each of those little lines. So 500, 500, 500, and so on all of those. And that tells me the weights of each of the ingredients that I need to put in the potato cakes or whatever it is. Yeah, potato cakes. Or Natalie needs to put in the potato cakes. So we need this much of potato. That's the first word, potato. And then this much of cheese and this much of onion. So cheese costs £2.25 for 175 grams. Work out the cost of cheese needed to make that. So how much cheese do we need? We need 1,000 grams of cheese. So 1,000 grams of cheese. How much cheese do we need to buy? Well, let's see how many 175s fit in to 1,000. So 1,000 divided by 175 is 5.71. So 1,000 divided by 175 is 5.71. So 5.714285, and that's recurring. If I was to buy 5 packets, it wouldn't quite be enough. So I'm going to need to buy 6 packets. So 6 packets are needed. 6 packs of cheese. And so then I'm going to do £2.25 multiplied by 6, because it's £2.25 for each of the packets. £2.25 times by 6 is £13.50. It just says 13.5 on my calculator, but because it's money, I'm going to do 2 decimal places there. So £13.50 would be the correct answer. If you didn't round it, so let's say you did 5.71 multiplied by £2.25, you did still get the mark there. So sometimes on deli counters, you can buy exactly the amount that you need, and so they did take that into consideration. So if you did that, the answer would have been £12.85 or £12.86. So you could have got £12.85 or £12.86 if you did just multiply the 5.71 by the cost. I assumed that it was packets, so I went for timesing it by 6 and I got £13.50, but any of those answers were absolutely fine for full marks, so just bear that in mind. Okay, question number 24. A water tank is empty. Anil needs to fill the tank with 2,400 litres of water. Company A supplies water at a rate of 8 litres in 1 minute 40 seconds, and Company B supplies water at a rate of 2.2 gallons per minute. 1 gallon is 4.54 litres. Company A would take more time to fill the tank than Company B would take to fill the tank. How much more time? Give your answer in minutes, correct to the nearest minute. Okay, so on these comparison questions, you guys will probably know that I like to split the page and have Company A over here and Company B over here, just to make it really clear for the examiner to see where my working is coming from. Now, Company A can do 8 litres in 1 minute and 40 seconds. So 8 litres in 100 seconds. But we've got to do 2,400 litres, and that is 300 times more. So we're going to multiply that time by 300. So 100 seconds multiplied by 300 is 30000, so 30,000 seconds. But remember that there's 60 seconds in a minute. I found it easier to make it 100 seconds rather than trying to times 1 minute 40 by 300, because you've got the minutes is 60 seconds, so it's quite hard to multiply that. So I've just made it 100 seconds, times it by 300, and then taken that 300,000 and divided it by 60 to put it back in minutes. So 30,000 divided by 60 is 500 minutes. So it would take 500 minutes, and I want to keep it as 500 minutes. I don't want to convert that to hours because I want my answer in minutes, the difference between them at the end. So for Company B, we've got 2,400 litres of water, but we know it fills at a rate of 2.2 gallons per minute. So what I want to do is change this 2,400 litres. If I want to get from litres into gallons, I'm going to divide by 4.54. So 2,400 divided by 4.54 is going to get me how many gallons that is. So 2,400 divided by 4.54. There are so many ways you can do this question, by the way. This is just the way that it makes most sense to me. 528.6343612 gallons. And then we know that it can do 2.2 gallons per minute, so I'm going to divide that by 2.2. So divided by 2.2 is 240.288346. Then it says how much more time does it take? So that's minutes. That's how many minutes it takes for Company B. I now just want the difference. So I'm going to do 500 minus 240.288, and then round that answer to the nearest minute. So in my calculator, I'm just going to do 500 minus answer. That's going to use that rounded answer. It's 259.711. So to the nearest minute would be 260. And you could have got that from a lot of different methods. So hopefully you've got 260 as your answer. That way makes the most sense to me, but you might have done it a different way. So yeah, 260 was your answer. Okay, question number 26. In a bag, there are only red counters, blue counters, green counters, and pink counters. A counter is going to be taken at random from the bag. The table shows the probabilities of taking a red counter or a blue counter. So far we've got these two filled in, but we don't have the green or the pink. The probability of taking a green counter is 0.2 more than the probability of taking a pink counter. Okay, and we know that with probability, this needs to add up to make 1. So complete the table. So far, 0.05 add 0.15 adds up to 0.2 or 0.20, however you'd like to think about it. And so I know that between the green and the pink, I need to do 1 minus 0.2, which is 0.8. So if you had no idea, you just need to make sure that these two values add up to 0.8. That'll probably get you a mark. So making sure you've got two values there that add to make 0.8, but we need to make sure that the green is 0.2 bigger. Now the way I like to do that is to say that, well, if x is pink, then green is x add 0.2. And then together we know they need to make 0.8. So I'm going to write x add 0.2. So both of those things added together needs to equal 0.8, which is 2x add 0.2 is 0.8. Take away the 0.2, which means that 2x is 0.6, and so x is 0.3. And then I know that this one is 0.3 because that's x, and this one is 0.5 because I need to add 0.2 to it. And you can now see that they add together to make 0.8, and this one, green, is 0.2 bigger. There are 18 blue counters in the bag. Work out the total number of counters in the bag. Well, blue is 0.15. So 0.15 equals 18 counters. And I want to get to one whole here. So what would be a good amount to get to? Well, I think it'd be easiest to work out 0.05. because I can get to that really easily, and I know that 100 is in the 5 times table, so that makes sense. If I can get 0.05, I can then multiply that up to get one whole or 100%. So I'm going to get that by dividing by 3. So if 0.15 is worth 18 counters, then 0.05 is 3 times less, so that's going to be worth 6 counters. Then if I want to know what one whole is, you could of course just then work out each of them individually and add them all up if that makes more sense. But I think here if I want one whole, so if I want to know what all of them are out of, then I'm going to get that by multiplying by 20. And so if I times that by 20, it's going to be 120 counters. 120. The other way of doing it is to say, well, this is 15%. 15% is 18, so you can get 5% and get 100% if it works for you easier like that. Or you can say, like I said, this one is 6 counters, this one is 18 counters. You then know that 0.5, that's going to be 60 counters, and 0.3, that's going to be, what's that times by 6, so 36 counters over there. And then you could add all of those together, and that would add up to 120. So there we go, you could do it that way as well. Right, question number 28, sketch the graph of y equals 1 over x. Now this is a reciprocal graph and it looks like this. So we have a curve on this bit like this and a curve on this bit like this. Now, how could we work that out? Well, normally we do a table of values. So I've got 1, 2, 3, 4, 5, for example. That's 1, 2, 3, 4, 5. You can think of it like that. 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 and so on. So that value is coming down and down and down and down, and that's why it makes that shape. So 1 to learn. That's your reciprocal graph. Hopefully that makes sense. That's 2 marks there. 38 marks in total. Well done if you followed along and watched the whole thing. And remember to join me next week for week 25. If you've got any questions, please comment below. I'd be more than happy to help.